All right, so let me shift gears now and talk. Let me start with initialization lists and a rationale for their existence. I wonder if I have it. No, I don't. There we go. Now I do. All right. Let's create a class. Let's see. Let's give it a name. I don't know. What's something that has two integers? Oh, let me see. Is that what I want? Let me think about this for a minute. No, I want this one to have a string. I'll call this. We'll do name. How about first name, last name? That's private. Public. And then we're going to call this then name. I'm feeling real creative today. We create a constructor for it. It takes a string fn and a string ln. And then what we end up doing is we do this. We add that. And we say that fname equals fn. Last name equals ln. And now let me create a class called, let me put an error statement in. Sierra in name constructor. Create another class. We'll call this class family. And the class contains daddy, mommy, child, all right. There's always a bad one, right? There's a constructor for this. Family. Name.
What's up with that first semicolon?
That's just, it's the Piazza hands. So it's a variant on jazz hands. Name, mommy, name, child. Okay, TOWSNBM. Okay. Let's write that constructor real quick. And I'm going to do a quick 4YY, P to paste, get rid of those. And I say equals D, M, C. I don't want to retype that. I'll just go there, get rid of that. And let's put a Sierra in family constructor. All right, let's see what we got here. Let's create a family. Oh, criminy. I don't know if this is such a good idea. Name. All right, we're going to get uncreative here. A is Bobson. It's the Bobsons. You can't disown him, he still has your last name. He or she. And that's C, D, F, A, B, C, D. I think we're all ready for this not to compile. It isn't going to compile. Anyone want to tell me why? And the reason is because of line 6. It isn't because there's anything syntactically wrong. I don't think there's anything syntactically wrong. I didn't intentionally put syntactic bugs in here. But a combination of having line 6, and then by default 12 through 17, but having line 6 and having, I guess, lines 23 and 26. And you get to see the fireworks on line 29, I guess.
Tries to construct the family with default values.
So here's the deal. In 111, hopefully you had classes. In 111, you would create things without any problem. Here, it will not let you create names because if you never create a constructor for a class, the compiler will write a constructor for you. It'll write a constructor that takes nothing. The minute you write your own constructor for a class, the compiler no longer writes that for you. What that means is line 7 is the only way you're ever able to create a name object, meaning that if you do not provide 2 strings while in the process of creating a name object, you're just simply not allowed to do it. Now the reason this thing doesn't work is let me find the first error. I always want to look at the first error of these things. No matching function call for a default constructor. And it's, interestingly enough, it's pointing the finger at the closing parenthesis of the definition to the family function. It says it's expecting 2 arguments and none were provided. Then there's a bunch of other crap that's not worth looking at. You just look at the first error on all this stuff. So let's pretend for the moment that there's like a display function for this. Now my question is not whether that's going to print useful information, but would anyone challenge me that that is a legal line of code for me to do on line 33? Or let me really drive the point home. The very first character coming out of the blocks of this constructor definition. I'm sorry, not D. I meant daddy. None of you had a problem with 34, right? In fact, let's forget about this display. Let's run with this right here, right there. No one's going to challenge me and say that that's not legal. So the assertion we can make is by the time you reach the open curly brace, daddy already has to exist. Yeah? Which means if it already exists, that means it was already created. And we have already seen that the only way to create a name, remember daddy's a name, the only way to create a name is by giving it 2 pieces of information. So there's a special syntax provided to allow you to initialize, that's why it's called an initialization list, to create and initialize your private data. And the syntax for it, so I'm actually going to change up this constructor a little bit. What I'm going to do is I'm going to, let me show you the syntax for it. It is between the end of this parenthesis, that's why it was freaking out here on what's now line 31, it was line 30. I'm on column, I'm way over here. It's freaking out because it's right at this point that you see the initialization list. Now we know that spacing is really flexible in the language and you can put it right here. I like to just start it on the next line unless it's a tremendously short function just for my eyes. And then the next thing you do is you name all the private data. And we can see the private data is on lines 25 through 28. So it's daddy, and you parentheses and comma, mommy, child, and now I got to do this. He's always this way, making me mad. Right. That's the first step in doing the initialization list. You list all of the private data with empty parentheses. The reason I'm saying that over and over again is I get a lot of this. No, that's not a private data. I don't even have to say private. That's not a data member of the class. That's the name of a type. Right? Don't put the names of types. Put the names of the variables that are data for the class. Next, you have to fill these in. Now we know that we need to provide two pieces of information, a first name and a last name for each of these, so I actually have to change up the function a fair amount. And I think what I have to do is abandon this method of creating the family and go to a different method. So what I'll do is, yes, we'll talk about copy constructors in a little bit. And I'm going to put these on different lines just so, let me see, how do I want to do this? 3yy, paste. Those become commas. And then I'll make it all look nice. All right. So you can see that what I have here are 8 arguments to this function. 1, 2, 3, 4, 5, 6, 7, 8, and that goes away. So there are my 8 arguments to this constructor, which means I have to go here and change this to something horrendous like first. These are now strings, right? String, first name 1, string, last name 1, string. Yeah, and now we do editor tricks. And there are commas after these 3, and that one ends. I'll leave it like that, a little more readable. And I have to take these same 4 lines, and I have to go down to this definition here and paste them in. I'll leave it like that again, no semicolon. And then there's my initialization list. All right, now I'm ready for step 2. Put in the arguments. fn1, ln1, I really chose a terrible example for all this. This is just crazy. All right. And then these are 4. Whoops. These are 3, 2, 2, 3. So now those 4 pieces of data are created via the initialization list, and I'm able to provide the arguments to them, right? So I can call that 2-argument constructor that is part of the name class. I guess I should try it. Now all this becomes unnecessary. So this stuff is 111, 211, 311 type stuff right here. You don't do that anymore. I'll leave it there as a lesson for others. And then these go away because I just put them all in here directly. All right, so I should have all that. Let me make sure I don't have any weird stuff in here. Leave that in. Oh, let me bring this up. I'll do it over here. G++ standard equals. We go for the latest and greatest. And this was this. What was this called? Oh, I'm in the wrong directory. 2019-02-22. Nope, 21. No input files. Oh, first try. Doesn't do anything. Oh, it does. I forgot about that. I put those error messages in there. So it's calling the name constructor 4 times for the 4 names, and then the family constructor, right? Here's the thing is, there are reasons for doing it that go beyond simply making it so that we can call this constructor, because what you could have done before I did all that editing and changing of the call to families, I could have done this. I could have created, in fact I just make it empty, not do anything. I could have created a default constructor, and then after creating that default constructor, I pass the 4 names in like I originally did, and then I do the assignments down here. Now, why am I against doing that?
That would allow someone to exist without having a name.
Oh, right. Okay. So there is an argument to be made for that. And that's a good argument. The reason I gave you, in the fact it's the motivation for removing that default constructor as soon as you write your own, is the language designers are saying, if you create a constructor, then that means, by golly, you know exactly how you want objects created, and no one should be allowed to create an object any other way, because it has the nice side effect, since you wrote that constructor, you can ensure that every name object ever created is always created validly. Right? So then the name doesn't have any valid value. Now, this is a discussion about what are the application requirements. Is it valid to have a default name that has John Doe in there or something like that, right? And that's a discussion you have with the other software engineers and maybe with the customer and so forth. But when it comes right down to it, you do have the capability of forcing people to use classes your way, and that they're never allowed to create an object if it isn't valid, by controlling what constructors they have access to. So that's one argument. But there's another argument to be made, which is regarding efficiency. So we already decided that, so let me introduce that by looking at this equal sign. For every class that you write, there is an assignment operator that is created for you if you don't write it yourself. Did you know that? So we didn't write it, but the compiler did provide a name reference operator equal const name reference n. So that is provided for you, and you can go ahead and write it. What's it going to do? It's going to say this first name is equal to n dot first name, and you do the same for last name. Okay, so that's what the compiler does if you don't do it yourself. So keeping that in mind, we had, when we hit this line here, with these ones I commented out, we all agreed that these variables already exist. So four constructors had to be run to get to line 51, right? We're looking at the scenario where I create a default constructor. 4 default constructors did run because they did create those 4 objects. Next, 4 more functions are being run on lines 53 through 56 because the assignment operator is always a function. So now we have 8 function calls. And there are about 30 million families created every hour on this application. So now instead of, 30 million function calls, I got twice that. But it gets even worse because what I had here is I had name, D, name, M, right, these. Everyone remember from 111 pass by value semantics where the arguments are their own variables? Those variables are actually created. Well, if these variables here on line 42 are actually created, a constructor had to run to create them. So that's 4 more functions. Now we have 12 functions. And so the argument for an initialization list is you reduce the overhead of all the functions that you call in order to create and initialize these things. Because the overhead does get real. We're talking about a simple toy class. You get into something real like a compiler or whatever application you're doing, and you have classes within classes, and hundreds and thousands of these things are being created. The overhead does get real in wasted function calls that you have. So it's very much a thing of optimization. Let's look at this. We can improve on what we see here. String is not a built-in type of the language. It's like int or double, and you can see that with the editor syntax highlighting. If I type int or double or char, they all turn green, but if I type string, it doesn't. Why is that? Let's say it again. It's a class, which means someone wrote it, right? Some software engineer wrote it, and they were lucky enough that it became part of the standard. Well, if it's a class, then what has to happen on lines 47 through 50? There are 8 constructors running there because you have to construct each of these. Remember that it's passed by value, so you get a copy of it. So there is a constructor running. It's a copy constructor, and we'll set that discussion aside for the moment. But that's inefficient. So how can I avoid, let's look at, how can I avoid a constructor being called for fn1? Pass by reference. Right, so what you want to do is put a reference symbol after these. It doesn't change the way you call it. It only changes where you declare it and define it, so I actually have to put it up here. Let me see. Current line, the +3, search for G, replace with G, ampersand, there we go. Doesn't change, again, this doesn't change at all. These are C-style character arrays. These actually get promoted to strings, which means constructors run to create temporary strings. But those temporary strings then come in here. fn1 is actually just another name for that temporary string. It doesn't create a whole new variable. That's a little bit dangerous. That means that, let me get rid of the temporary string on one of these. I create a string, fn1, Bob, and now what I do is I pass in, let me call it first, I'll just spell it out. All right, with what we were talking about a couple minutes ago, fn1 on line 17, excuse me, on line 47 is a copy of the variable that we created on line 65. So a constructor ran to create fn1 on line 47. By adding this, fn1 is no longer its own variable. It is merely referring to a variable that already exists. So in that case, 47, fn1 is now merely referring to first name. The danger in that is I can do stuff like this. Assuming that function exists. Right now, In the old C pass by value world, who cared if someone did that? That's just screwing up an input parameter that no one who calls the function cares about. But now I can do real damage to anyone who calls my function. And so what I need to do is I need to make a promise to those people that I won't change their function, or that I won't change their object by making this const. That's a guarantee to the compiler, right? The only difference is whether or not your program compiles. It all runs the same. It's a guarantee to the compiler that you will do nothing that tries to change fn1, and if you do, it won't compile. And here I'm trying to do something that changes fn1, so the compiler would hang on this line and not compile. So this is kind of the end of the story for parameters that are of class type: string, date, family, name, symbol table, symbol. If you're passing it into a function, you pass it by reference to save on function so that you don't create new ones. Second, if the function is not designed to change it, then pass it in by constant reference as a guarantee that you promise not to try to change it. Because if you do, it won't compile. So that means that all of these do that. This is something that will set you apart between if you start your first job programming C++. This is going to show you as being a seasoned developer, not an amateur. That you understand the difference between pass by value and pass by reference and the guarantee that const provides. Okay? Initialization lists. We don't really need them for integers, or let's say floats. So let's say that the family class has a float. I don't know, the family's grade point average. This is a built-in type. There is no constructor for it. If I wait and I just do this, that's fine. However, there's something to be said for consistency. Oh, it's hard-coded in there, which is fine, by the way. Even though I don't earn anything as far as optimization on line 56, oh, there's no semicolon, it is consistent with every other piece of data in the class. So here's the general rule, and this is what I'm going to require for everything you do from here on out. I have to think if there are exceptions. I'll talk about the exceptions in a moment. If it is a data member of your class, you have to create a constructor for the class, and you have to have an initialization list for all of the data of the class. If you do not have your data in the initialization list and you're doing this kind of thing, that's 111 amateur hours, what that is. Okay, don't do that anymore. The exception is occasionally it isn't as easy as knowing what the value is. You may have to go interrogate a database and get a response back, in which case you may not be able to put it up here. You may have to have some functionality down here to get a valid value for a data member. So there are exceptions, but by and large, whenever you're designing and writing classes, you should always be trying to shove everything into the initialization list. Okay.
So besides the exceptions, is there any other reason why any code at all would be in the brackets?
Yes, absolutely. There are all sorts of reasons, and I have to try and conjure up an example real quick. Yeah, maybe the class is managing, among the other things it does, maybe it's managing a log file and you have to go ahead and log an initial entry in the log file, right? I don't know. I don't like that example. It's kind of a lame one, but it's an honest one. There's always situations where you have to do some sort of algorithmic work in the constructor.
Can you put any code in the initialization list?
Any legal expression can go in the initialization, not in the initialization list, as the argument to the data member. Any legal expression can go in there.
That's fine.
You can do 5 plus 10. You can hard code 3.14.
So I could do like a function called lookup.
Absolutely. So if you want to abstract all that database lookup into a function, you can just put database function call here. And whatever's returned would initialize GPA. Of course, you would want it to be returning a float in this example. Yeah, any legal expression.